So number one, which amino acid has a net charge of plus 0.09 at pH 7? So plus 0.9 will tell you, will indicate that this amino acid has to be the member of the basic amino acid group, because at pH 7, this amino acid can have either plus charge or neutral charge. So for the basic amino acid group here, you have only three members: is either lysine, arginine, or histidine. So to calculate the net charge of lysine, arginine, histidine at pH 7, you have to know the different form of each amino acid and determine which form will be predominant at pH 7. We first begin with lysine. So lysine have three different pKa. The first one is the pKa of the carboxylic group, which is 2.1, and the second one would be 9.6. Is the pKa of the alpha amino group, and then the last one is equal 10.5 is the pKa of the side chains of lysine. So the most protonated form of lysine would give you plus 2 charge, and then the second form of lysine will give you plus 1 charge, while the third form of lysine will give you neutral charge over here, and then the most deprotonated form will give you minus 1 charge. So now you can see that the pH equal 7 would be fall over here. So this is the pair that you need to work on here. So if you want to calculate the net charge at pH 7, you have to use the Henderson-Hasselbalch equations. So pH equal pKa plus log B over A. So B in this case would be lysine neutral charge, while A would refer to the lysine's plus 1 charge here. So pH is 7. pKa in this case, we use 9.6 because it's in between the form that we focus on right now. And then you can calculate for the ratio B and A here. So the ratio of B and A will be equal it will look like this. So B will be equal 0.01, while A ratio would give you 0.99. So since from the diagram we can see that only acid species would give you plus 1 charge. So to calculate the total net charge here, you need to using the equivalence and the chart to figure out what is the net charge at that certain pH. So A acid ratio will give you plus 1 charge, whereas the basic ratio give you neutral charge. So to calculate the total net charge, you have to use the equivalence times by the charge of that structure. So for the basic part, the total net charge would be equal 0.01 times by 0. Whereas for the acid ratio, you would have 0.99 times by plus 1. So if you calculate the total net charge over here, it would give you the total net charge of plus 0.99, right? So that is not match of what we want. We want plus 0.09. So lysine is not the answer. So what's about arginine? Arginine also have 3 different pKa. The first pKa would be the pKa from the alpha amino, alpha carboxylic group 2.1 here, and the pKa of the side chains of arginine is equal 12.5, so that would be the last pKa here. While the second pKa would be the pKa of the alpha amino group. So again, is the most protonated form of arginine is +2 charge, and then you will have less one charge over the other. So the third form of arginine will give you a neutral charge, and then the last form of arginine will give you the -1 charge. Same as lysine that we did previously. So now it's still this pair that you need to work on because because plus 0.09 is fall in between these. So again, you use Henderson-Hasselbalch equation to solve for the ratio A and B and then calculate the total net charge of arginine at pH 7. So, okay, so using the Henderson-Hasselbalch equation, pH still 7, pKa, in this case we use 9.6, and log B over A. So if you got B and A right, you will have B equal 0.01, same as lysine, right? Because it's the same pKa here. Why your acid ratio will be 0.99. So again, B ratio give you a neutral charge. So total net charge would be 0. While A ratio give you 0.99, and this is give you +1 charge. So the net charge will be plus 0.99. So the total net charge here would give you plus 0.99. Again, this doesn't match what we want, 0.09. So arginine still not the answer that we're looking for. Then comes to the last candidate of our answer here, histidine. The histidine side chain has pKa equals 6. So pKa of the side chain would be the second one. The first one still be the pKa of the alpha carboxylic group, and the last pKa would be the pKa from the alpha amino group here. So pH 7 for right here, right? And then the most protonated form will still be +2, and the most deprotonated form is -1. So as the diagrams show here, that if you want to calculate the net charge at pH 7, you need to focus on this pair. Again, using the Henderson-Hasselbalch equation to solve for the ratio B and A. So pH is 7, and now the pKa that we plug in is 6. So it's different from lysine and arginine. And then you calculate for either B and A. You will get B equal 0.91, while your A would be 0.09. So B ratio gives you the neutral charge, right? While A ratio give you +1 charge. So in total, B would give you 0, while your A ratio will give you plus 0.09. So total net charge of histidine at pH 7 would be equal 0.09. So that's why our histidine is the answer for these questions.